let's do this. Okay, so assignment 2 is worth 10%. This is a brand new assignment, okay? One file, okay, not multiple files like previously. There's no late submissions because we've already given you an extra week. Plagiarism, watch out for it, okay? Don't do it. The file that you copy from Unix is unique to you. It might look very similar to other people. Some of you might have found some of the traps in it, but there are more. Okay, I can guarantee you won't pick them all up. If you copy stuff from other files, it will pick it up. So don't. Okay, don't do it because it's going to be extremely obvious. Okay, so make sure that it's your file and your file alone. Blah, 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 blah. All right, chemicals, we don't really care about them, blah, 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 blah. Okay, we get to this point. I don't really care about the chemicals, okay? We don't really care about the chemicals, okay? And that's important, okay? When solving a problem, don't get too deep into the domain. Try and just simplify it into what you have to do, okay? So here, basically, we have chemical equation, okay? And what we want to see is this side equal this side, okay? And basically we do this by grabbing the letter and multiplying it by the little number next to it. If there's no little number next to it, then it's 1, okay? It may appear in the first part or the second part of each of the reactants or the products, okay? So we might need to grab it twice. So in this example, we've got C3, we've got 3 Cs, we've got H8, we've got 8 H's, we've got O2, so we've got 2 O's on the left-hand side. On the other side, we've got 2 H's. We've got an O here and another O here. This O is 1, this O is 2. 2 plus 1 is 3. We've got 1 C, okay? We can see that these are not equal to each other. Does that make sense? Okay, if you're here, I want your participation as well, so I know you're following along.
Yeah.
Sure. All right. We also have another element, which is our coefficients. So this multiplies everything that's in one term, okay? So this does 3 times whatever's here, and this does 4 times whatever's here. This does 5 times whatever's here, okay? So here we've got not 0, I mean O and then times 2, we've got O times 2 times 5, which gives us 10, okay? 5 times 2 is 10. I think everyone gets that. Does that all make sense, or is there anything unclear about that? How it's formatted, we can't do this little subscript, so it's just going to be written with a large 2, okay? But it still makes sense, okay? So just be aware of that. All right. The data entered by the user will be in the correct format, so you don't have to worry about that. You do need to worry about this, okay? A lot of students forget about this. Any compound, don't hard code them. An element will not appear twice in any single compound, but it may appear in both products or both reactants. Okay. Blah, 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 blah. And you know all this. Okay, cool. All right, so now we get to the fun stuff. So I'm just going to grab the code. Why didn't I? Actually, I think I can grab it from my folders. Where is it? Where is it? Where is it? Where is it? PS. Students temp. Temp. Oh, I'm going to download it. Give me 2 seconds. I just need to connect to VPN. some reason. What's going on? Password. All right. So in this question here, we're writing function descriptions, which you've been practicing doing in the lab. So I'm going to grab these two bits of code that are given to you. Yes. 2020. Sorry, I opened the wrong server. Sorry. Sorry about this. We will get to it in a sec. I'm just grabbing the code from your version. So I'm not sure. All right. Yeah. Oh, I just realized I had it on the screen the whole time. All right. So we've got two functions. Okay. We've got this numeric car. Now I'll just mention this quickly. Actually, I don't really need to. I just want to mention something about how to write this. We'll go through how it works later through an example. But when writing this, okay, big couple of big mistakes that a lot of students do when writing function descriptions. Okay, so first thing, we write our description. Okay, we write our parameters. We write what it returns, and we write some notes. Okay, description. Description should be from the function's perspective. There is no user here. There's no print, there's no scanf. Don't mention the user, okay? There is no user here. Only look at this when you're writing your descriptions. Don't look at main. That's the biggest mistake that students make when writing descriptions, okay? The description to this should be nice and simple, okay? It shouldn't be super technical, okay? You can put your technical stuff in the notes. Just explain basically what it does. This function takes a ASCII character that is numeric and converts it into a decimal integer. Okay, as simple as that. Okay, that's all we need to know. The parameters, the ASCII numeric character. What does it return? The decimal integer. Notes, how does it work? Okay. So you've got to explain this, and this is explained in the video in week 3, literals in other bases, okay? So if you have a look at that video. Does that make sense how we write a function description and why we don't talk about the user?
Yeah.
Okay,
yes.
Talk about it from the function's perspective. If you want some examples, go Google POW, go Google square root. Go Google some of these math functions that you've been using and see how they describe themselves, okay? Printf, scanf are a little bit complex. They're actually very complex. So I wouldn't look up those. You can if you want, but POW, square root, some of these nice math functions are really simple and they have really nice function descriptions on the internet. Okay, so you can Google those. Actually, I'll just do that for you. Okay, so POW C. Okay, and this is a good way to learn how to write these descriptions. So I've just Googled POW C. Okay, description. Raises the power, X raises the power Y. Okay, you can see how simple it is. It doesn't talk about any technical parts. It doesn't talk about C. It just tells you what it does. Okay, the parameters. What it returns. Okay, you'll notice here where it says returns, it doesn't say double. Double doesn't tell us anything. We can see that from the signature. Okay, so with your descriptions, they should be descriptive so that anyone can pick it up and know what's going on. All right, now what we're going to do is we're going to do the entire task. So what we're going to start with is looking at what this whole thing does. Is this still recording? All right. So I'm just going to grab this. And we need an example. So we need lab sheet, assignment sheet, sorry. Okay. So I'm going to skip over this because we don't really care about this. I'm going to skip over this because we are going to do that in a second. All right, so let's pick our example. I don't really like that example. I think I like this example. This example's good. So I'm going to use this example here to do the entire assignment. Okay, and we're going to go through it step by step, and then you're going to understand it. You'll be able to write excellent comments, and you'll be able to test it, debug it, printf, and see if you get the same values as I mentioned. All right, so here, right at the start, we print our student number. Then we've got a printf, okay, which is our chemical reaction balance check. What I'm going to actually do is I'm going to do my box and pointer diagram on another sheet because we're going to run out of room really quickly. It's going to end up really big. Okay. We then have 4 lots of dynamic memory allocated. Okay. Now we've got this macro, which is 128. Okay, so we've got 128 characters. So each of your reactants and products can be up to 127 characters. Why 127? Because you've also got that null terminator. Okay, so with strings, okay, keep this in mind. If you've got the string, say, if you've got the string, say, hello, okay, this is 6 characters because in memory, it stores H, E, L, L, O, null terminator. And that tells us where it stops. And this is really good because we can put anything in, as long as it's less than 127, it will stop automatically once it's finished. So let's add these to our diagram. So we've got, how much shit do I need in main? I don't know. So we've got our main function, and I'm going to do this kind of big because I don't know how much memory I'll need. So we've got main, and we've got 1, 2, 3, 4 pointers. Okay, this is called reactant 1 original, reactant 2 original, product 1 original, product 2 original. This is a caster, 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 caster. And then we've got some memory on the heap. Okay. And we have four lots of cars. Okay. Now be patient. This is going to take a while to draw, but it will be valuable. Oops, I'm going to hit shift. Now I'm not going to write all 100 and whatever. I'll just put ... and that means that it goes all the way. Okay, so obviously these should be 128 long. And I'm just going to put ... to save us some space. Remember that malloc returns a pointer. So if we come back over to main, Okay, we've got a pointer to this guy, got a pointer, sorry, I want this to be as neat as possible. This is going to get really messy, okay? Just letting you know. So box and pointer diagrams are very messy. Okay. So we now have something that looks like this. Does that make sense? Awesome. Yeah, mine's gonna fucking explode in a second. All right. Then we call this getCompound function. Now we've got a description of what getCompound does. Let me grab it. GetCompound. This function should ask the user for a compound. So we're asking the user, if we're asking the user for something, we're going to print to them, okay, indicating the number n. So we've got a format specifier there. Then should store the string response from the user. Okay, so let's have a look at this happening. So we've got a getCompound. And we've got some literals there, which is nice. So we've got our getCompound function. So at the moment, remember that we can only call one of these at a time. So I'm talking about this first one here. So what we're doing with getCompound is we pass the function a pointer. Okay, so a caster. I think it's called the same thing. Where's the function prototype? Yeah, it's called compound. Oh no, it's called compound. Cool. So it's called compound. And then we've got n, which is called n. Okay. From our main function, we pass in the values, this first pointer. So we now get this pointer all the way up here. Okay. And we pass in the number 1. Okay. So what you'll see is that we have this address of this memory here. So that's really handy because we can use scanf with that. So we can print to the user, printf, blah, and we can use this n, okay? And then we can scan. And we can scan and pass the address. Now remember that this is a pointer, so we don't want to put the ampersand, okay? Because we don't want the address of this, we want this address. And we can use %s for our string. So let's say that the user entered our example, which was C3H8. Okay, does that make sense? And then there's a null terminator here. Okay, so these are all characters. Remember, it's a character array. A string is just a character array. There's this null terminator here, which means everything after it's just ignored. Now, once we're done, we return to main. Okay, when we return to main, this means that this function's and its data within it is gone. Okay, so when we call it again, it's a brand new function. Okay, in terms of memory. So we now do the next step, which is the next compound. Okay, don't worry, I'm not going to do it in as much detail. Okay, so we call the next one. So we get another getCompound. Okay. We pass the value 2, and we pass a pointer we should use a different color, but to the second one. Okay, and then we enter the values, which are, sorry, I'll use a darker color, 5, 0, 2, null terminator. Can you read that? I hope you can read that. Oops, what did I just do? I do not want that. Well, maybe I do. Yeah, I'll leave it like that. Okay. So once we're done with that function, it's gone. Okay. And we've got the value in there. And we do this 2 more times until we've got all the compounds. No, I don't want that because I can't see my thing. All right. So we'll enter the other ones. So just pretend that we called them, and we get 4 H 2 O, null terminator. And we have 3 C O 2, null terminator. What I might do, just because we're going to be using these a lot, is I might tidy these up before we go any further. Okay, so I'll just tidy these up. Don't worry, we're going to go through this all in depth. I know it's slow, but at least it means that you've got every little bit of information. So I'm just cleaning this up so that it's really easy to read, because these are going to be used. All right, so I'll just do these again, nice and clearly. So we've got C, 3, H, 8, null terminator. We've got 5, O, 2, null terminator. We've got 4, H, 2, O, null terminator. I don't really care about the null terminator too much. 3, C, O, 2, null terminator. Okay, so that should be a little bit easier to read. Does that all make sense up to this point? So we've done the first couple of steps. Okay. So for those that were stuck on that part two, that should hopefully explain how that works. Now, once we've done that, we can check, okay? So this is the point that you check, does it print it out, okay? Remember that now the values are here. When we print these, if the stuff is in here, then it should just print out whatever's in there. Okay, and that's what these checks are for. Okay. Now we've got another set of pointers. And all they're doing is taking a copy of the original ones. So we'll add this into our box and pointer diagram. We might make main slightly larger. Okay, so we've got 1, 2, 3, 4. And this is reactant 1 copy, reactant 2 copy, product 1 copy, product 2 copy, and they're all car stars. Now, when doing box and pointer diagrams, using that shorthand notation of C star, that's perfectly fine. So we'll take our copy and we're just going to point it at the same thing. What if there's a better route? I'll make this clearer. Just do this. Okay, so you can see that it's starting to get a little confusing. We're starting to get a lot of arrows and pointers all over the place. That's okay. As long as we take it slowly, we'll know where everything is. Okay, so these copies should just point to the exact same thing as these original ones. That all good. Cool. All right. So where are we up to? This is still assignment 2. Cool. Okay. And then we get to this get coefficients. This is where it gets interesting. So the first thing we do is we create an array. Okay. Now this array is not dynamically allocated. Okay, it's statically allocated. So this is going to be in main. So we've got an array, which is called coefficients. Okay. And it's of type int, and it has 4 spots. Okay. Now we're going to call the function get coefficients. And I'm going through this. I don't expect very many students to get the comment for this right or perfect. Okay. So we're going to go through this and take some care to listen. All right. So where's our get coefficients? I'll just grab the get coefficients. Get coefficients. There it is. So get coefficients is pretty ugly. Okay. It's pretty ugly and we've got to call it. Okay, so I'm going to draw it out now. And where are we? So go back to the background. So I'm going to write my function. Okay. And then we'll show what gets passed into it. So we've got the get coefficients. Get coefficient. Okay. And all it has at the start is a compound pointer, which is a car star star. Now with your box and pointer diagrams, remember that a car star star can only point at a car star, meaning it can't point to any of these. It can only point to these 8. Okay? So that gives you a huge clue. Now if we go back to our main, we'll notice that we pass the address of Reactants 1 copy. So if we pass the address of Reactants 1 copy, that means that it's not pointing at the data, it's pointing at the pointer. And this is really important, okay? This is fundamental in how this works. Okay, so we've got a pointer that points to here that goes back all the way up to the top. We've then got a variable that says coefficient. So it's coefficient, and it's an int, and it's defaulting to 1. We then get to this line of code here, which says star compound pointer 0. How do we dissect this? Okay, so if we dereference compound pointer, we end up here. Okay, and if we go to index 0 of what it points at, then we get the C. Okay, we get the C. Remember that square brackets is just dereferencing. Okay, when we see square brackets, what it's actually doing is pointer arithmetic. Okay, so keep that in mind. So when we have the square brackets, it dereferences and grabs the index 0. So it grabs that C. Okay, so we now ask the question, is C greater than the number 1, or is C less than or equal to the number 9? This is where you need to go and have a look at your literals in different bases to explain this, okay? Now, we know that this is false, okay? So once you've studied that, we know that's false. So the if statement doesn't happen. So we return 1. Now, this 1 gets stored in index 0 of the coefficient, so we get a 1 here. Does that make sense? Multi-layers, this is good. Oh, whoops, I don't want to get rid of that. Does that make sense? Awesome. So now let's have a look at one that doesn't have that. Sorry, I mean, it does have a coefficient. So let's go back to main. And you'll see that this is where the power of get coefficients happens. And you can see how it removes our pointer. Give me a sec. Let me just do one thing and then I'll be back with you. Just need to grab the share participants invite. All right. So now we'll have a look at the second one. And the second one's a little bit more interesting because it does have a coefficient. So let's have a check of this. So here, this time, we're passing in the reactant 2 copy. Okay, so it means that we get an address up to reactant 2 copy. We then do exactly what we did before. We dereference that pointer and grab the value at index 0, which is the number 5. Okay, so we've got the number 5 now. Now, is 5 greater than the character 1 and less than or equal to the character 9? Yes, it is. So then we go inside of our if statement, and we've got coefficient numeric char to decimal int. Now we know that this takes our numeric char and turns it into the number 5. Okay, once again, literals in different bases. Lab, week 3. There's a Big video on it, really important video. Okay, so it takes that and gives us 5. So we get 5 inside of our coefficient, and then we do something interesting. So we say dereference compound pointer becomes dereference compound pointer plus 1. So what does that mean? So let's have a look. Dereference compound pointer gives us this address here. Plus 1 is this address here. Okay? And what we're saying is dereference compound pointer becomes this one. So this is no longer pointing at the start, but it's pointing to plus 1. So it's moved the address over by 1. And then we return the coefficient and we get 5. Now, let's have a look at why this is significant. Okay, so I can get rid of that now. And I'll get rid of all the other stuff. And let's have a look at why that's significant. And how the magic happens. Oops, I got rid of the 1. All right. So this second one, this copy, isn't pointing to the start anymore. The original is still pointing at the start, but the copy isn't. And this means if we go and print this out, it'll print 02 because it thinks that the string starts here. It doesn't know anything about it beforehand. Okay? It doesn't, so it's starting here and it doesn't know anything about it beforehand. Okay? So if I do %s, it will just print it directly out. Okay? It also means if I dereference, this is now index 0. This one isn't. Okay? So if I go and use reactant to original 0, it will give me 5. Reactant to copy 0 gives me O. Okay? Does that make sense? Or is it something that you want me to recap? One yes. So it looks like it's removing the coefficient, but it's not really. Okay, and that's the important thing. And we don't want to remove it because we've got to free that memory, remember. Okay? So we don't want to get rid of it because later on we want to be able to free it. All right, so now we're pretty much, we have everything. So we do that 2 more times. So we know that we'll get 4 and 3, and these pointers will no longer point where they're pointing, but will be updated and pointing at the thing in the second spot. You'll notice this first one didn't change because it doesn't have a coefficient. Are we all good with that? All right, let's go have a look what's next. It's in the template. Okay, so there's a little bit of a testing for remove characters from string. We can actually do that. It's kind of isolated. I might not worry about that. Okay. So remove characters from string we don't need yet, so I'm not going to worry about it right now because it's kind of isolated from the problem. It's like kind of a sub-problem. Right. So now after that, what we want to do is combine our strings. Okay. So, sorry. Okay, so we're going to combine our strings. All right. And so what we need to do is work out how long our strings are, and we need to declare enough memory for them. Okay. And this part's a little bit difficult. Okay. Because a lot of students forget about a couple of key points. Okay. Where are we? So I just want to grab the lab sheet as well, because I think it asks you to do it in a slightly different order, but that's okay. Do we have lengths? Shit, did I give you the lengths? Oh, shit. Okay, sorry. I was getting confused because I didn't copy one page part. Like, I'm sure I gave you that. That would have been unfair. Okay. So we've got string length, and this function is deceptive. Okay, and this function you need to be careful about. A lot of students will get this wrong the first time, and you probably won't notice anything, but you might randomly segfault. Okay, and this is where you need to be careful. So if I've got, don't do this to me. If I've got two strings, hello and hello, how much room do I need to store these? So remember, this is 5, this is 5 in terms of characters, but it's 6 in terms of what gets stored because we've got that null terminator. Now we don't need 2 null terminators if we join these together, we only need 1. So to store hello, hello, we need 11 bytes of memory, okay? Not 10, okay? And I think a lot of people probably forgot about this when they were declaring memory for these 2 lines here, okay? So let's add these lengths to our box and pointer diagram. So we've got some ints. Probably need to make main a little bit bigger again. This is where a whiteboard's nice, but unfortunately we're not in a classroom. Why is my eraser not working? Let me just clean this up a little bit. All right, so we're going to create 4 ints, which will give us the sizes. 1, 2, 3, 4. Okay. So I've got reactant 1 size, reactant 2 size. I think I've called it length. Sorry. Reactant 1 length, reactant 2 length, product 1 length, product 2 length. And they're all ints. Okay. And we just get the string length. Okay, so that means the length of the string without the null terminator. So here, what we've got to remember is that we're passing in the copies. So it's going to measure the length from the pointer. So the first reactant goes all the way up there to here. Maybe I should do that in a different color. Whatever, it's too late now. All right, so 1, 2, 3, 4. So that gives us 4. The second one we come across and we start here. So the length is only 2, okay, because it's starting from that O. We then go to the next one, which we follow that crazy line around and we get 1, 2, 3. Then we get the next one, which is 1, 2, 3. Okay. So if we're going to join these together, okay, if we're going to join these together, then what we've got to remember is the fact that we need that null terminator as well. So for the reactants, how much space do I need for this example? Well, I get up string cat. So how much space do I need to store C3H8O2? 7. Beautiful. All right. So we need a generic formula for this. So we know we need a malloc here. Okay. So we need some kind of malloc, and everything's going to be size of car. And then we need to times it by something. And bracketing is going to be important. Okay? If you don't bracket this, it means something slightly different. So what goes in the bracket? Well, as you said, we want the length of this plus 1. Okay? The plus 1 for the null terminator. Okay, does that make sense? All right, so what I'm going to do is I'm going to draw this really quickly, and then we'll have a 5-minute break, and then we'll keep going. So let's do this first, just quickly, and then we'll have a little bit of a break, and then we'll come back, and we'll do the entire thing. Is this helping as well? Just for interest? Cool. So we've got reactants, and we've got, what's the other one? Products. Because I know that some of you had specific questions about specific steps, but I find that if you don't have a really good understanding of the base, then it makes it really hard to understand some of those more complex steps. Because I tried to cover them on Wednesday, and it was kind of, people just wanted answers. So I think this is kind of a better way to approach it. All right, so we dynamically allocate memory, okay? And as you said, we created 7 for the first one, and we should create 3 plus 3 plus 1, which is 7. So we got 7 for both, which is nice. So we've got car, and at least now we've also got some extra memory. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and then we return a pointer. And we return a pointer. Okay, so that's what your malloc's doing. It's giving you 7 spots for both of those. So you got 2 mallocs there. Size of car times something plus 1. All right. And then we'll talk about string copy and string cat when we get back from the break. All right, so let's have a 5-minute break. We'll be back at 11:05. Sound good? Okay, you're all here. Beautiful. All right, so now we're going to look at string copy and string cat. So reading documentation is important. In IT and engineering, there's a lot of documentation. So you need to get used to it. So I've got the definitions of both of these here. So we'll start with copy. So the C function, string copy, copies the string pointed to by source to the destination. Okay, so it takes source and copies it into destination. Destination is a pointer to the destination array where the contents is to be copied. Source, this is the string to be copied. So we know the order to put these in. It also returns a pointer to the destination string. Okay, we don't really need this. Okay, because we've got that pointer anyway. Okay, so you can ignore the return value always. Like printf has a return value, but we ignore it. Okay, so we can copy strings into each other using string copy. We also have this other function here called string cat. Okay, so this basically appends, so adds to the end of the string pointed by source to the end of the string pointed to by destination. Okay, so you've got destination and source. Destination, this is a pointer to the destination array, which should contain a C string and should be large enough to contain the concatenated resulting string. Now, if we did the calculations correctly before, they should fit. Source, this is the string to be appended. This should not overlap the destination. Okay, so we know what they do. So let's see them in action. Let's close that, and let's do it. Okay, so we're going to do string copy first. Okay, we're taking Reactants 1 copy and putting it into Reactants. So we go to Reactants 1 copy. Okay, that's the source. Okay, I've lost my pen. So we're going to copy that into our array. We'll just use black. So we go C, 3, H, 8, null terminator. Okay, so we've copied that string in. And then we go string cat. So we take Reactants to copy and add it to the end. Now the end of the string, we know because of this null terminator. Okay, and so does string cat. So we go to Reactant to copy. Remember, it's starting from the O, and it will copy the O to null terminator. So it gets rid of this, and we get O to null terminator. Beautiful. Okay, and then we just do the same thing with the other one. So we have H to O null terminator, then it will concatenate. So it'll get rid of the null terminator, and add C, O, 2, null terminator. All good? Awesome. Okay, and then we do a check to make sure that they copied across correctly. And that gets us through part 4. We then keep going. So we then get to part 5. So we uncomment part 5, which I'm just doing, and I'll copy and paste it into here for you. So we've got part 5 there, okay? Pre-part 5, which is a call. Okay, so this is a function call. And let's just have a quick look at what we're passing. So we're passing an array. Okay, so it's a pointer. We're passing another array, which is also a pointer, another array, and we're passing 2 values. Okay. These are pointers, don't forget that. Okay. So let's have a look at this function. So let's go over, actually let's, before I do that, let's put the function in here. It's balance check, yeah. Because there's going to be a lot happening here. Okay. So we've got our balance check function, which looks like this. Okay. Now, what we're going to do is we're going to draw the box and pointer diagram for this. So what I'm going to do is we'll go over here. We'll do it on this side. Okay. So a pen. And this is going to be a pretty big function because it's going to do quite a lot. So this is our balance check function. Okay. Zoom in. And we'll just go get everything ready for it. Okay. That's that. So I'm doing this layout. So we've got a int star. So we've got an int star called coefficients. We've got a char star called reactants. We've got a char star called products. We've got our reactant one length and our product one length. So product one length, that's an int. I've got product one. Oh, whoops, reactant one. That should be an R. Length, and that's an int. Okay. So we'll start with that. So what gets passed in? We get passed coefficients, reactants, products, reactant one length, and product one. And they're the same name, so that makes it nice and easy. So actually, let me do something to make this a little easier for us. What I'm going to do is I'm going to move this down. Maybe I'll move this underneath. That might be a better spot for it. Yeah, I'll put it there. Because we don't need anything at the top anymore. Just need stuff at the bottom. All right. And what I might do also, just to make it clearer, is these lengths those out of the way for a sec. I'm just moving some stuff around so that it's easier to see on the screen. Right here. It's back. Hey, where they belong. Can you stay there? I really should have done this on a transparent layer. Let's delete those. Sorry, give me a sec. I'll move to a transparent layer as well. Just so this isn't much of a pain in the future. Okay, cool. lost one of our pointers. Okay, so the reason I've done that is because we don't really care about anything else. We just care about this and this. So our coefficient passes this pointer. Okay, remember with arrays, we just specified the name. We're just talking about the pointer to the start of the array. So our coefficient points to this array in main. Our reactants points to the reactants. Our product points to here. Our reactant length. Our reactant one length is 4, and our product one length is 3. Okay, is that all good? Oh, I was going to move to a little later as well. All right, so now we've also got some more things. So this is getting more and more complex. Kind of want this as well. So we're going to introduce some variables. Okay. And we've got, there's a lot of variables here. Okay. Balance, which is an int, and it's 1. We've got num atoms, which is an int, it's a 1. We've got an array, which is 3 long, which is an array. I'm just going to call it current element. Remember that it's an array. Okay, so I've got that pointer to the start, and it's 3 long. I take reactant 0, so I go up and grab reactant 0, which is C. Okay, 0 is the null terminator, so we've got 2 null terminators there. Okay, and then I've also got I. Hopefully that's enough variables for you. All right, so now we need to have a look at the document and have a look at the steps. So where are they? So we've got a for loop here. We'll talk about that in a sec. Okay. So let's have a look at how this works. Small. Okay, so we come in to our loop, and I is currently 1. Okay, I is less than string lengths of reactants. Okay. Okay, remember the string length of the reactants is 6. Okay. Plus 1, so less than 7. Sorry. So we go into our loop and we check, is reactants I a lowercase letter? So reactants follow the line. We're going to index 1, not index 0. So that would be a 3. Is that a lowercase letter? No. Okay. Else if reactants I is a numeric character. Is it a numeric character? Yes. Yes, it is. Okay. It is a numeric character. Okay. It's a 3. So we go into this part of the if statement. then the numeric character is converted into a decimal integer using the appropriate function. Do we have a function that converts a numeric character to a decimal integer? Yes, we do. And basically we call that, and the number of atoms is set to that value. So we've got number of atoms here, and that's going to which layer I'm working on now. It gets set to 3. Please don't tell me that is. So that gets set to 3. Because it's an else there, we skip it and go back up to the top. For loop, I++, we get 2. Okay? So now we go, if reactance I is a lowercase letter. So we go back up. Is H a lowercase letter? No. Okay. So we then go, is it a numeric character? No. So then we go, else. Check this is correct by printing out the current element and the number of atoms. So we do a check here, and we should print out C3. Okay, so in our current element, we've got C and we've got 3. So we should print out C3 here. Okay, you can make it formatted like this. Okay, so current element should be printed as C and number of atoms should be printed as 3. Okay, then set the number of atoms back to 1. So set this back to 1. And the current element 0 to reactance I. So we know that's H, so we'll put H there. Okay, well that too. Okay, come back on the for loop, and now we've got 3. So we go to index 3. I didn't do any with the lowercase character. That's going to be kind of annoying, because we won't be able to test a couple of things. That's okay. That'll give you a challenge. So we get an 8. So 8 is not a lowercase letter. 8 is a numeric character. So we call the appropriate function, and we set this to 8. We then come back up. I gets incremented, so we get 4. Okay. So we grab the 4th one, which is an O. Okay. Is O a lowercase? No. Is it a number? No. So we've got the next one, which would be H8. Okay. Then set the number of atoms back to 1. And the current element 0 to reactance I. So this is going to be a big O. Okay. Then we come back up and we increment this to 5. And we get 2. Now we're going to do this all over again when we add in part 6. Okay, but I want to go through it anyway. So we add a 2. So it's a numeric character, so we get a 2 here. Okay. So we come back up. This becomes a 6. Index 6 is a null terminator. Okay. Definitely not a lowercase letter, definitely not a numeric character. So we print it out and we should get O2. Okay. We come back up, this becomes 7. 7 is not less than reactants. Does that all make sense? Okay, so that's how we do part 5. Now, what you'll notice is that we're only printing out with our checks these two variables, okay? But if you want to, you can print out some of these other variables as well. Okay, you've got lots of variables there that you can use to double check that it's correct. Okay, if your I is like 14 or something, then you obviously know something is wrong. Now what we're going to do is we're actually going to do this again because we're going to add something to it. Okay, so blah, 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 blah. Where are we? All right, this is perfect. It's so tiny. Shit, this is the version with the answer. I should get rid of that. To do that. All right, so we've got a for loop. All right, so we've basically got this inside the for loop, okay? Where what am I doing? All right, so here we're checking lowercase. If it's lowercase, we set it to this second character. Now we didn't have any examples of that in our problem, okay? But I think you know how to set that to the second character. Okay. Else if numeric, then we set number of atoms. Else we do this part. And I actually give you the answer for how to reset the current element there. Because I'm being nice. Okay. So this time we do it, we're now going to call another function. Okay. And this is where everything starts getting even more complex. Okay, but what we can see is that this is still fairly logical as we're going along. So I'm going to reset this back. So we've got C at this stage. I is 1, and number of atoms is 1. How do you check if a lowercase character? So that'll be using what you know about ASCII literals. Okay, so as I said, really go study that video in week 3. And also, you can use this resource. Where's the ASCII characters? You can use this resource and you'll see that the way that we're doing the numbers, okay, is because they come one after each other. The way we can do lowercase characters is we can see, is it greater or equal to character A or less than or equal to character Z? Okay, that's how you can check if it's a lowercase. All right, so now we've got another function. All right, can I do this? How should I do this? Do I give you the template? Or just give it to you empty? What function are we doing? Total. Right, it's empty. That's okay. Let's do it with the steps. Yeah, do it with the steps. Right, so now we've got to find some room. So what I might do is I might split this up, and we're going to add another function in here, which will give us step 6. I think I'll go away. Okay. So this function here is going to be our get total reactant elements current element. What a name. Get total reactant atoms current element. All right. So this function here, we've got the prototype somewhere. I think I've got the prototype. Pasting seems to make it too small. Do it this way. Is it clear? All right, so we have quite a few things to put in here. So we've got the coefficients. So that's a pointer to instar. We've got reactant 1 length. We've got the reactants. Now, do we have, I just want to double check something. Okay, it's the second one. All right, so we'll do the second one and we'll check it. We've got the reactants, which is a caster. We've got the current element, which is also a caster. We've got the number of atoms in atoms, which is an int. We've also got this variable I. Right, so get rid of that now. Don't need that. So we've got that there already. All right, and then we pass in the matching names. Coefficients, reactant 1 lengths, reactants, current element, number of atoms, and I. So, oh, we're not up to that anyway. All right, so let's do this loop again. And we've got that ready to go. Okay, so we're at the start of the loop again. Okay, so we're going back in time. This is the very first time we've gone in the loop. Okay, so just imagine we're back at this point here. Okay, we're back at this point here. Come in. We check if the reactant at index I is a lowercase. No, it's not. Okay, is it numeric? Yes. So our number of atoms changes to 3. Okay, we then go I++, and we get a 2. Okay, we then go check index 2. Is it a lowercase? No. Is it a number? No. So now we go into the else. And this is where we're going to call our function. Okay, total reactants, current element, get total reactants element. So we pass the coefficients in. Now this is passing a pointer. So it's just passing this address. So now we've got this going all the way up back to main. That's okay. All the way up to here. Okay, so I know this diagram's looking complex, but you can see that we don't have this array done multiple times. We can just follow the arrow and we get to it. We don't have these written out multiple times anymore. Okay, we've just got one copy of it, and that's the only one we're using. Okay, and this is going to be really handy. And this is so you've got to remember that when I designed this, it was from scratch. And when I was designing this from scratch, I would hate to have lots and lots of arrays. I want lots of pointers instead, because it just tells me where to go. So reactant 1 length is 4. The reactants is over here somewhere. Probably should use a different color. So the reactants are somewhere up there. Go around this way. Okay, so that's the reactants. All right, so we're copying that pointer. You'll see that there's a lot of crossover between these. They're pretty much the same. A current element is also a pointer. Okay, it just points to the current element. Number of atoms is 3, and our I is 2. Does that make sense? So only one person. I think so. So we're just passing the values in. Okay. We're just calling this function and passing these values in. Oh, we'll need a little bit more. That's okay. We'll also need to create a variable a little bit later once we've gone through this function. Okay, so now we're inside this function and we've run out of room. All right, so now we're inside this function. We're going to have a look at the steps of the function. Screen. Let's just do it in 2 parts. Okay. All right, so check if the current element is part of the second reactant using the variables I and the reactant 1 length. So what we can know is we've got this 4 here. Okay. So if we have a look at the indexes, okay, we've got 0, 1, 2, 3, 4, 5, 6. Okay. Now we can check if it's are we checking if it's part of the second? Yeah, we're checking if it's part of the second. So I at this stage, remember that it comes after. Okay, so I is 2 at this stage. Okay. The reactant 1 length is 4. Okay. And so we want to check if it's part of the second half. Okay. So when we're doing, say, H8, okay, we're going to have 4. So we don't want to include 4 in our comparison. We want it to be greater than 4. Okay. So here we've got our first if statement, okay? And we want to check if I is greater than our reactant one length, okay? That will check if it's in the second half, okay? All right, so it will check if it's in the second half, all right? So we're using the fact that we know where the next part starts. We're using our I variable to work out where we are, okay? So we're not in the second part, okay? We're in the first part. So if we have a look at this diagram, this is false, so we're going to the else, and we're going to do number 3. And this is where we're going to use str, which is string inside of a string. Okay, so what we're trying to do is seeing if we can find our string again. Okay, so the way that str works, okay, is basically we choose a point in our array. Okay, so I've chosen index 3. From that point, I'm looking for ELL. So I'm looking for this ELL. And if it appears, it should give me the pointer right here of this E. Okay. So let's do that. Okay. So we're going to do str. We're going to store the pointer of that. So it's a caster. I think I've called it lock pointer. Okay. And we're going to pass in the address of reactants 1 length. Now, why do we do reactants 1 length? Because where we want to start searching from is from this point. Okay, we want to start searching from 4. We want to see if it's in the second part. Okay, so that's why we choose reactants 1 length. So we're going to pass that address in. Okay, and what we're going to be looking for is our current element. Have we got a pointer to that? Yes, we do. So we want our current element. Okay. So we need to check if it's not null. Okay. If it's null, then it's not in the second half. Now in our example, C is not in the second half, so it should return null. Okay. So if log pointer not equal to null. Okay. So we've got that down. All right. Where are we? I think I've got 2 open. Okay, so this for if fails. So we go down to this else, this 10. Okay. So 10 tells us the current element is only in the first reactants, and you can calculate the total reactant atoms for the current element, as you have the coefficients of the first reactants and the number of atoms. Okay. We also have a variable. I forgot about that variable. So this is the total, and it's just the so we're going to step 10, okay? And basically that says we've got the number of coefficients, so we can get our coefficients. We know that our coefficients is going to be at index 0, okay, because we're in the first half. So we can go coefficients 0 times number of atoms gives us our total, okay, for step 10. Which should give us 3. Okay. We all good with that? Okay. So the rest of this example is fairly straightforward of how we're doing it. Okay, so that should give us all of these values. Okay, but what we might want to do is just have a quick look through these steps with some examples that would work well for these examples. Okay, so what we might do is just have another 5-minute break, and then we'll do just some examples of step 6 so you can see every stage of this. How's that sound? Or is that enough information? Oh, I forgot to mention that this returns that T, that total. So we have another. We have another variable there. Why is this going so slow? Okay. All right. All right. So I won't go through anymore because it's just going to be the same thing going 3 times because they're not very interesting. Except for the last one will be the second half. I think the one that'll probably get most people is the step 5 and 6. So I'll just do an example with steps 5 and 6, and also step 9. Yes, I'll do another example, and we'll just pretend that we've done all that first half. So what we can do. All right, so let's have a 10-minute break because I've been talking for 2 hours. And then we'll come back at 12 and we'll do a couple more examples, or one more example for step 6. How's that sound? Sound good? Cool. All right, let's have a 10-minute break. Ugh. All right, we all still here? Awesome. So I put together this example here. So we've got our coefficients, so just 2, 4, 6, 8. Reactant 1 length is CL8O. Okay, so that's our reactant 1. Our reactant 2 is CL2. Okay. Our current element is Cl. Okay, so we're looking at this first one. and our I is currently at 3. Okay, so I is currently here. Okay, remember that it's always one more ahead. So we're going to have a look at how this is done. I think this is a really good example to show this. Okay, so the first check is checking if the if it's part of the second reactants using I and reactant 1 length. We did this before. 3 is not greater than 4. Okay, so why am I on the wrong document? So check if it's part of the second. It's not, so we get into the else. We then get this string. Okay, so the address of reactants 1 length and the current element. This will give us something back. Okay, this will give us where CL is back. So we've now got another pointer, which I'll add in. I didn't bother drawing it last time because we didn't use it, but I will make sure that I draw it this time. So we've got this location pointer, and it's caster, and it's pointing at this CL. Okay, so we've used str in step 3. Okay, so this is step 3, and we've got that location. So this time we don't get null. Okay, we actually get that location. Does that make sense? So remember str. Okay. Okay. We pass in the address of the second half. Okay. So we pass in that address of the second half. Okay. And it will search through it looking for whatever's here. And it finds it straight away. It's CL. So it gives us that pointer back. Does that make sense, Sharon? So str will just look through a string and see if it can find a word within it or a letter. Okay, so if I have, let's say, Matthew, and I want to see if it contains the, it will give me a pointer back here. Okay, because it found the word the. Okay, if it can't find the word within the word, then it will just give me null back. The other thing about it is that we're not starting from the start, because starting from the start would be pointless because we just get the first one again. So we start from here. We start at the second part. Cool. Okay. Now, step 4, we check if location pointer is not null. Okay. So we check if it's not null. So it's not null. So now we go to step 5. Store the string length of the current element into a variable named length element 2. Okay, so we need another variable. It's a length, so it's going to be an int length element 2. And we're storing the length of this, which should give us 2. Okay. Okay. So we now have quite a bit of information. Why can't this go on top? What's going on? There we go. We then check if the current element in the second reactants is followed by a numeric character using the location pointer and length element 2. Now there is a couple of ways you can do this. We have a pointer right here. We also know how long this is. Okay, we know it's 2 characters because this is 2 characters. Okay, so we want to see what happens at this point. Now, what's location pointer index 0? What would that give us? C. So what would location pointer length of 2 give us? No. 0, 1, 2. Gives us the 2. Okay? So we can get that. Okay? If it's one character, this would have been a 1, and it would have given us the character after it. If it's too long, then it will give us the character 2 from it. So it gives us that 2. Okay? So we check if it's a numeric character. Okay, in 6. Is it greater than equal to character 1 and less than or equal to character 9? Yes. So we get to step 7. Okay? So step 7 means that we've got a lot to calculate. So we've got the coefficient of 0 times this NA plus the coefficient of 1 times this value here, which is location pointer location 2. And that will give us the amount. Okay? So this will give us 2 times 8, which is 16, plus 4 times 2, which is 8. Okay? Add those together and we should get 24. Now, does that make sense? Okay, so we're just deciding what to include in our calculation depending on which half we're in. Okay, so there's 3 possibilities. Okay, so we've got 2 halves. Okay, the value is in the first one, but not in the second one. The value is in the first one and the second one, or the value is in the second one and not in the first one. Okay, if it's in the first one, there's just coefficient 0 times NA. If it's in the second one, it's just coefficient 1 times number of atoms. If it's in this one, then it's slightly more tricky because now we've got, oh, can you stop being stupid? Plus coefficient 1 times the value that comes after it. Okay, does that make sense? So they're the only 3 options there are. Okay, there's nothing else other than that. Now we've got one last thing to deal with. The problem with it being in the second half is that if we leave it there, we're just going to end up doing it twice. Okay, so we want to get rid of it. Okay, and this is where you need to call your function that you did in step 3. Now we haven't talked about that function. So let's have a quick chat about that function. Okay, and what that'll do is it will remove all this. Okay, which is what we want. Okay, we want to be able to remove this second one because we don't want to evaluate it twice. So let's go to step 3. Part 3. Okay. So here in part 3, we'll just do the example. Example's easy. And this is very, very, very similar to the lab this week. You did a like a copy function. It's kind of similar to that. So where's the prototype? Grab the prototype. Let's just grab the function actually. So we've got this function here. Okay, you can do this with pointer arithmetic or not. It's up to you. If you do it with pointer arithmetic, I will be impressed and I'll be happy. But if you don't, that's also perfectly fine and I'll be happy. But if you do it with pointer arithmetic, I will be more impressed. Okay, it's not too difficult to do with pointer arithmetic. So I'll do the solution without it so that you can prove yourself. All right. So what we want to do, let's see what it says. We'll do it using this one. Okay, so we want to shorten a string. So we're going to have a for loop. Okay. That starts at 0 down to the length, string length of our string minus none, I++. And then all we're doing is we're saying string at index I becomes string at index I plus none. So you can do a string I becomes string I plus none. That's it. Okay. And what does that do? So let's have a look at an example. So we've got the string hello. Hello. Terminator. Okay, so I is 0. Okay, let's say we put in, let's just do the example. So let's say we put in 2. Okay, so string I, so this is 0, becomes string I plus none. So 0 plus 2 is 2. So it's going to be L. So this one becomes L. Come back up the loop, I is now 1. String 1 becomes string 1 plus 2, which is 3, so it's this L. And you can see here that you can do a printf here and check that it's working. Okay. Come back up, it's now 2. Okay. We now get our 2 plus 2 is 4. Okay. So we get this O. Okay. So you can see how it's overriding the start. Come back up, it's now 3. Okay. We grab the null terminator, put it there. Come back up, it's 4. I is now greater than string length. String minus null. Does that make sense? Awesome. So finish off the assignment. Make sure that everything's working. And then when you're prepared and ready to really prove yourself, do step 7. Okay. Awesome work. I hope that was a lot of help. And yeah, I have recorded the whole thing, so I will download it. It'll probably take like a day to download, but yeah, I'm gonna go. But yeah, thanks for coming, and hopefully that's a lot of help. See you.